Can you see my Canvas web page?
Yeah, we see the screen.
Okay, this is the Canvas web page. I'm going to show you where you can get resources for Chapter 3 and 4. Module 2. You click on here, Module 2. So we go to Module 2 right here. When you go down the Module 2, at the bottom there's a sample questions for Chapter 3 and 4. You can watch this video about Chapter 3, question and answers. Last year, I discussed about it. I'm going to add a Chapter 3 for this year. It will be on the way now. I am also going to add Chapter 4, question and answers for this year. You can go to quiz Chapter 4, question and answers, part 1. And you can go question and answers, part 2. To take the test, you click on the bottom item in the Module 2, Chemistry 105, Test 2, Chapter 3 and 4. I send email and announcement telling you that your test is going to be on Friday. Friday is October 13th. All right? Friday is October 13th. So it will be open 8 to 10:30. 8 a.m. to 10:30. So you need to take it on Friday. So I'm going to review Chapter 4 today. You can look up for Chapter 3 review later, because Chapter 3 is the one we did. Chapter 4 is the one we did last time. So I am going to go to Chapter 4 review, and I'm going to put Chapter 3 review on the web page. All right. Do you have any questions? I guess not, huh?
No, sir.
Okay. I'm going to share the Chapter 4 slides and review some of the things we've done. You can also go back to Canvas web page and start reviewing. Do you see my Chapter 4 chemical reactions slides? Chemical reaction and energy calculations.
Yes.
All right. I'm going to go over mostly questions and introduce to the concept as we go along. I'm going to start from this page. We talked about type of chemical reaction, balancing chemical equation. We go on over these 8 topics. I'm not going to go over topics again. Chemical reaction, there are 4 sets of based on pattern synthesis reaction. You need to be able to identify, given a reaction like on the right, sodium and chlorine reacted in sodium chloride. That's a synthesis. There are single displacement reaction, double displacement reaction. You need to know exactly, based on pattern, how you identify these reactions. Based on reactivity, we done precipitation, acid base, and oxidation reduction reactions. I have classified chemical reaction based on pattern: precipitation, oxidation reduction, acid base reaction. Combustion reactions are also oxidation reduction reaction. Some of the synthesis reaction, as well as decomposition reaction. We gone over this. This is number 4. Identify the correct classification of reaction. Lead sulfate break into lead sulfide plus oxygen. That's a decomposition. If you look at the pattern, one molecule one compound break into 2 simpler compounds. That's a decomposition. D is the correct answer. This reaction, question number 7, the correct classification is synthesis. Now you need to understand how to balance chemical equations. You count the number of atoms on reactant side, product side, and balance by changing the stoichiometric coefficient number in front of chemical formula. We gone over this. When you have a hydrocarbon like third reaction, butane, if you start with even number of carbon atoms, you have to put a 2 in front of carbon 4, because that way easy to balance. If an odd number of carbon atom, like C3, you start with 1, easy to balance. For example, this reaction, carbon number is even. You start with the 2 here. Then put an 8 here to balance a carbon. To balance the hydrogen, 10, you put a 20, 10 here. To balance the oxygen now, 16 plus 10 is 13. Why 13? There's a 2 here. 13 times 2 is 26. So if you look at this, that's the balance equation. That's how you balance. You can do this reaction also. It's pretty easy. For respiration, this is the balance equation. Salt dissolved in water are found as aqueous ions. They are surrounded by water molecules, solvated ions. We talked about this. When 2 salt solutions are mixed, you get a precipitate. If one of these combinations, silver and silver chloride, make an insoluble salt. Sodium nitrate is soluble, therefore only one precipitate is formed. You can filter the solution and isolate the precipitate. Filter through a funnel with a filter paper. This precipitate formation depends on formation of an insoluble salt. The silver chloride is insoluble. So we talked about this. There are 3 types of equations. Complete ionic equation is when you have ions all broken down except the insoluble salt. All compounds are broken down to. When you have AQ in front of AQ after salt, that could be broken down to ion, silver ion, nitrate ion, right here. You cannot break down silver ion. This ion equation is called complete ionic equation. There's a molecular equation when you don't have ions, but the formula of compounds, that's a regular chemical equation. That's called the molecular equation or chemical equation. So these types of complete ionic equation right here, this is the same thing I shown here. They have ions found in both sides. They're called expected ions. When you remove expected ions, you get the third equation, which is called net ionic equation. Net ionic equation shows what really took place in the precipitation reaction. Since sodium and nitrate ions are present before the reaction, after the reaction, nothing took place. Nothing happened to them. Therefore, these are called expected ions. In this reaction, expected ions are nitrate ions and sodium ions. If you look at this reaction, this is a complete ionic equation. So expected ions are chloride. You find them on both sides. Also potassium. Therefore, potassium and the chloride ion are the expected ions. B is the correct answer. About the expected ions. Expected ions form solids insoluble. That's not true. The expected ions are solid ions. Expected ions form gases. In precipitation reaction, gas is not formed. One expected ion oxidized another. That's not true. There's no electron transfer. Expected ion do not participate in the reaction. That is the correct answer. In the complete ionic equation, you remove expected ions with the net ionic equation. D is the correct answer. Now we go over these rules, solubility. All these cations of group 1A. Group 1A is lithium, sodium, potassium, first group of the periodic table, and ammonium ion. If the salt is one of them, any cation, any of these cations with any of the anions are soluble. That's a general rule, most basic rule. There are two anions that are general rule too. Any anion except sodium and acetate could be insoluble. You have to follow the rest of the rules. Therefore, for sure, any nitrate, any acetate are soluble. So we go to the chloride, bromide, iodide, and sulfate. They are generally soluble. There are exceptions, 4 exceptions. You look in chloride, bromide, iodide, you begin to see except chloride, 2 chlorides here, silver chloride, lead chloride. They are insoluble, except 2 sulfate, barium and lead. Carbonate, phosphate, sulfide, hydroxide are generally insoluble. We're talking about insoluble. They are mostly insoluble, except lithium hydroxide, ammonium hydroxide. You have to be careful. Carbonates are generally insoluble except lithium, sodium, potassium, rubidium, cesium, ammonium. Those are general rules apply to any salt. Therefore, lithium carbonate, sodium carbonate, or any carbonate, ammonium carbonate, are soluble. Calcium carbonate is insoluble, is not group 1A. So, predicting the solubility of water, ions in salt in water, which of the following compounds is insoluble in water? This is acetate. Any acetate. This is a nitrate, soluble. This is calcium chloride. This is soluble. Carbonate. This is insoluble. I should have said insoluble here. These are soluble. Your question is insoluble. Therefore, insoluble salt is this one. IS, insoluble salt. Calcium carbonate. Any carbonate except group 1A or ammonium ion are insoluble. Which of the compounds is soluble in water? We have the silver chloride, lead chloride, and lead sulfate, barium sulfate. Therefore, this is not soluble, insoluble. These two are silver. This is soluble for sure. Let's go back, look at the silver bromide. They say sulfate are soluble. But for sure, most rule, any acetate is insoluble. Therefore, that has a most suitable answer. So D is the for sure. Which of the following compound? You can say this for sure. These two are soluble also, but this most prominent one is this. Which of the following sulfide is soluble in water? These are insoluble, silver sulfide, iron sulfide. This is soluble, lead sulfide is insoluble. Sulfide except group 1A, potassium is group 1A. Which of the following anions always form soluble compounds? Nitrate. We say any nitrate acetate, therefore is the correct answer. Acetate is the answer to 52. So therefore A is the correct answer. We are looking at a reaction where the precipitate is formed. Looking at this, A is the correct answer. A precipitate according to the beaker in the image. That's how it's shown. The gas formation reaction bubbles out. Precipitation reaction, cloudiness appears, depending on the color of the precipitate. Yellow precipitate, brown precipitate, white precipitate. Which of the salt could be precipitate in the beaker? This is the insoluble. This is soluble. These are not salts. These are metal and a cation. To become a salt, there should be a cation and an anion. These are salts, two salts. This is the soluble. Now you should be able to balance gas formation reaction. Carbon dioxide and water is produced. You check the formula. Calcium nitrate is this. This is wrong for calcium nitrate. This is wrong. This is correct. But this equation is not balanced. Out of these two, this is the only balanced equation. Therefore, answer is D. You need to be able to balance acid-base reactions. Magnesium hydroxide, base, phosphoric acid. So check the balance equation. You have to have the formula correct. This one is correct. This one is correct. This one is correct. 6, 12 waters. 12 hydrogen, 6, 12 times 2. That's 6. That's 3 times 2 is 6. That's the correct answer. This one is not balanced. Now we're going into redox reactions. Loss of electrons is oxidation. Gain of electron. We use the mnemonics. Leo says G. So zinc is oxidized. That's here. Copper is reduced. Reducing agent is one is oxidized. One reduce is the oxidizing agent. We talked about this. Which of the following most useful when dealing with ionic materials? Ionic materials are metals. We use loss of electrons. That's the correct one. Oxidation is, these two are used in only combustion reactions, where oxygen is lost or gained hydrogen. We're going to talk about definition. Generally, most useful are the loss of electron or gain of electron. That's the correct answer, D. Which is reduced in the reaction. Lead loses 1 electron to 2 electrons to silver. Silver becomes gain 2 electrons. Therefore, lead is losing electron, oxidized. Reduces this one. You look up in the product side. This is the species. Silver plus is the one reduced. This is the one. There's a stoichiometric. We don't put 2. That's understood. Silver plus is the one that is reduced. B is the correct answer. Oxidizing agent is again silver. Why? Silver get oxidizing agent is agent that is reduced. What is reduced is silver. Therefore, silver ions are the oxidizing agent. So, opposite of oxidation, we call it reducing agent. Reduced species are called oxidizing agent. Now, I gave you an example of reduction oxidation. Oxidation reduction take place in solution with metals. If you look at this zinc metal placed in a copper sulfate solution, zinc goes into the solution as zinc 2+, oxidized. Copper from the solution get deposited as copper metal. Metal has no charge. We call it metal copper 0. So this dark coat on the zinc metal is copper. Therefore, this reaction is reaction between copper and zinc metal. So we can use a galvanic cell or voltaic cell to show this reaction between zinc and copper. Zinc is oxidized. Oxidation number increase. Oxidation number is same as charge on the metal atom. This oxidation number is 0. Oxidation number 0 goes to +2, increase. Increase, oxidation number increases oxidation. Oxidation number decrease, this copper change from +2 to 0. That's a decrease, +2. Therefore, reduction is decrease in oxidation number. We use these ideas to create two half reaction. Oxidation half reaction, reduction half reaction. Zinc is the one being oxidized. That's the half reaction. Zinc oxidized, lots of electron. Copper gains electron. Copper is reduced. Reduction half reaction takes place at copper. If you create a galvanic cell, voltaic cell, also called voltaic cell, this is the zinc. This is the copper. This is the zinc sulfate solution. This is copper sulfate solution. This is the soul bridge that keeps the connectivity between two solutions. Current flows from electron is flowing from anode. Anode is where oxidation takes place. Cathode is where copper is reduction takes place at cathode. Anode oxidation takes place. Electron flow from anode to cathode. There are 2 electrons because copper gains 2 electrons, zinc loses 2 electrons. This light bulb glows or it lights up when the reaction takes place. This is a general idea about battery, electrochemical cell. So if you have a galvanic cell created between silver and zinc, that's the anode. Anode is written on the left side. Cathode is written in the anode oxidation takes place, cathode reduction takes place. Electrons flow through the wire, create 1.56 volts of electrical potential. So this is the zinc sulfate solution. This is silver nitrate, zinc nitrate solution. So if you look at this equation, what is the cathode in the cathode is silver. Solution is not the cathode. I cannot write. So that's the answer to the question. C. Solution is not the cathode. Metal rods are the cathode or anode. Zinc is the anode. In an electrochemical cell or galvanic cell, the anode is electrode at oxidation take place. So that's the correct answer. In this reaction, electrochemical cell, reduction reaction occurs at the reduction take place at silver. Therefore, you have to pick up the this is the reaction between zinc and copper, not the same. That's copper between copper and zinc. Reduction takes place at that. Reduction F reaction is A. So you have reactions that are combustion. They tend to be, they are also redox reaction. Carbon loses hydrogen. Carbon gains oxygen here. Carbon pick up oxygen. Carbon loses hydrogen. Therefore, oxidation can be defined as gain of oxygen or loss of hydrogen. Reduction is opposite. Loss of hydrogen, loss of oxygen or gain of hydrogen. This alternative description for combustion reaction and organic reaction between organic compound, we use the idea gain of oxygen is and loss of hydrogen is oxidation. We talked about that here. This one is oxidized. Therefore, oxygen is reduced. Then the reduction agent, oxidizing agent, idea similar to what we discussed. So for a combustion reaction, alternative description of reduction and oxidation could be used. Which are the following oxidation? Oxidation of gain of oxygen. Loss of hydrogen is loss of electron is not, that's reduction. Loss of hydrogen. Loss of hydrogen is reduction. These are correct. I didn't look at it. So loss of electron is also oxidation. These are including all of metal ion solution, galvanic cell, and combustion reaction. All these definitions are correct for oxidation. Reduction is opposite of what is in here. Gain of electrons. Loss of hydrogen. That's not true. That's oxidation. Gain of electron is reduction. Gain of oxygen is not true. Only correct answer for reduction there in the list is A. So if you look at this reaction, this is oxidized, this is reduced. Which species is oxidized? That one is the formaldehyde. Therefore, answer is A. We can go through some of the questions. I am only showing you basic stuff. Which of the following are production of incomplete combustion? Incomplete combustion produces carbon dioxide and water, carbon monoxide and water. Normally it goes to carbon dioxide and water. Therefore, this is the correct answer. This is not water. That's wrong. This is the correct answer. Bleachers are oxidizing agent. Which are the reduce? We already talked about it. Reduce is silver. Oxidize is this. We talked about this. Now we're going into the stoichiometry using gram-mole conversions. How do you get the formula mass or molar mass. This formula weight is also called molar mass. Molar mass of water or formula weight is 18. You add up two hydrogens, and which is atomic masses, one each. 16 is the oxygen atomic mass, you get 18. How do you convert grams to moles? You divide it by 18, you get 2. So grams to moles conversion uses grams divided by formula mass. This is the formula mass inverted. That's the division. You get the moles. Grams divided by formula mass. Grams multiplied by moles to grams is direct multiplication of moles with formula weight. How do you calculate formula weight or molar mass? It's expressed in grams per mole. Formula weight also shows how many grams are in a 1 mole of substance. From the periodic table, sodium is 23, chlorine is 35.5. You add them one to one. So you get the formula mass or molar mass for sodium chloride. For this compound, nickel 2-chloride hexahydrate, you get adding up all the atoms. For water, we also calculated 18 grams per mole. So there are questions where you can calculate the molecular weight is for covalent compounds. Covalent compounds have molecules. You add up 12 carbon, 22 hydrogen, 11. These are all multiplied by subscript atomic masses. You get sucrose is the sugar we use in coffee or beverages. This is sucrose, molar mass of molecular weight. That's the correct answer. So getting formula mass is pretty easy. You add up masses of all the atoms in the formula. Ionic compound, we call it formula mass or formula weight. Molecular compound, we call molecular weight. We also call molar mass for either ionic compounds or covalent compound. Mole is an important concept. From the formula mass, it's given in 1 mole of that material in grams. It's obtained from formula weight. Carbon 12 has a molar mass of 12 grams per mole. That means 1 mole is 12 grams of carbon 12 isotope. That is the standard for measuring chemicals in terms of moles. We use atomic mass unit is same as 1 gram per mole. Is same thing, different use. We mainly use grams per mole. A mole contains same number of formula units. Avogadro number is this number, mostly rounded off to this second decimal place, 6.02 10 to the 23. So iron has that many, methane molecules have that many molecules, sodium ions have that many sodium ions. Therefore, formula unit per mole is called Avogadro number or Avogadro 6.02, 10 to 2. It's a large number. How do you convert grams to moles? They're asking in 5.63 grams of sodium sulfate, how many sodium ions are in? This is a little complex. There are 2 sodium ions in therefore there are twice as many moles as sodium moles. First, how do you get the moles of sodium sulfate? You have to get the formula weight. You calculated adding sodium, 2 sodiums, 1 sulfur and 4 oxygens, 142.1. That's the formula mass. Formula mass, grams divided by formula mass. This is the grams we got from this number, 5.63. Divided by formula mass. 1 over 142 is division by formula mass. You get, that's the moles of, there are twice as many moles of sodium in the ions. Therefore, it's going to be 0.6. This multiplied by 2, you get that number. 1 mole of sodium sulfate has 2 moles. That's the conversion factor. 1 has 2. That's how you calculate formula mass and get the moles. If you look at helium and beryllium, these are molar mass or atomic mass. 1 mole of helium weighs 4 grams. Beryllium, 9.01 grams is a mole. They contain same number of helium atoms and beryllium atoms. Helium is heavier than, 1 mole of helium is heavier than. That's not true. Helium is lighter element. Therefore, it has 1 mole less weight. Beryllium contains more atoms. If this is 1 mole, molar masses, they contain the same number of, more than 1, that's not only 1 correct answer. So C is the correct answer. That one. Mole contains same number of helium atoms and beryllium atoms. So if you look at this, 1 mole of this contains 2 moles of hydrogen, 1 mole of sulfur atoms, 7 moles. How do you get 7 moles of atoms? 2 hydrogen, 1 sulfur, 4 oxygen. Adds up to 7. Therefore, correct answer is more than 1 correct response. Because all 3 are, first 3 are correct. I am doing too much detail. So how do you calculate grams to moles? This is grams. This is the molar mass of aspirin. That's grams divided by formula mass of aspirin. You get the moles of aspirin. This is pretty, how do you get the number of molecules of, these are moles. Moles, 1 mole contains Avogadro number of molecules. Therefore, this multiplied by Avogadro number, 6.02, 10 to the 23, gives the number of molecules. That's how you calculate how many molecules are in 1 mole of 0.0020 moles of compound. If you know the moles, if you ask for particles, ions, molecules, you multiply the moles by Avogadro number, you get number of particles. Particles could be ions, molecules, etc. Avogadro number would have, argon would have 40, because if you look at the formula mass weight of argon is 40. Formula weight is given is grams per 1 mole. Therefore, formula weight always tells you, calculated from the periodic table, tells you number of grams in a 1 mole. Therefore, 1 mole should have been weighed 40 grams of argon. Seven moles of waste. Then how do you calculate molar mass? Molar mass is same as formula mass. Formula weight is same as molar mass. Grams divided by mole. So moles are given here. So 142 divided by 1.1782. This should be the answer. This is given molar mass is grams per mole. Sometimes we write AM. So that's the only correct answer. D. Same question. Similar question. Grams of water. How many moles of water? This divided by 18. You get the answer. Answer is C. Now it's easy to calculate moles from grams given the formula mass. Now we're going to look into stoichiometry. Stoichiometry is converting grams of products, grams of reactants to grams of products using any chemical equation. Now the idea is to use a chemical equation which is written in a number of moles, molecules. Normally chemical equation, stoichiometric coefficient in front of the chemical equation tells you how many moles, not the grams. Therefore, first step in the stoichiometric calculation is grams to moles. How do you convert grams to moles? Grams divided by molar mass of A. Then, depending on the stoichiometric coefficient, 1 to 1 here. Same number of moles is produced as A here. Now you go back to multiplying moles times molar mass or formula weight gives grams. If you started with certain grams, you calculate the certain grams of products. That is a stoichiometric calculation. We also call it theoretically. Let's look at, I'm not going to look into this. We go on over this. Let's look at some problems. If you look at this equation, when you are using in the stoichiometry, number of carbon dioxide moles produced by 9 moles of water. That's 6 to 4 right here. 6 moles of water produce 4 moles. Therefore, we have to convert the ratio. I write down based on the chemical equation. 6 here water, that's a 6, that's a 6. 4 here, that's a 4. That's the conversion factor. Now I simplify dividing this by 6. Now I get a fraction. Why I get a fraction? I have to get the 9 moles. Therefore, I multiply this both sides multiplied by 9. You get 9 moles of water. 2/3 of water divided multiplied by 9, you get 6 moles. That's how many moles you get carbon dioxide you get from 9 moles. That's the same question. You get 6 moles of carbon dioxide. A is the correct answer. Similar question. You calculated 2 molecules of how many oxygens react with 2 molecules of 2 molecules is 7. Therefore, it should be answer should have been 7 because it's already in the same ratio as in the chemical equation, 2 to 7. Therefore, answer is 7 moles. Answer is D. So these are the stoichiometric calculations. You calculate, convert the number of formula moles to another different formula moles, then multiplied by molecular weight or formula weight, molar mass, you get the grams. These are the conversion factors using moles relationship. Out of these, this one is not correct. I checked that out before. There's a 6 here between ammonia and water. There should be not 5, 6. Therefore, not consistent with the equation is choice C. So we convert moles to moles of different substance in the chemical formula during the stoichiometric calculation. This is a similar calculation. So these are all moles calculation. Now when you do a stoichiometric calculation, you normally start with grams, but we are doing moles right now to make it easy. If I give you grams of ethylene is this. Grams divided by molar mass of ethylene, you get that. I'm cutting out how many grams of ethanol can be produced from now grams. This is 1:1. Therefore, same number of moles of ethanol is produced. So how many grams of ethanol? This multiplied by molar mass of ethanol. Molar mass of ethanol is 46, I think. So 7.24 multiplied by 40 formula weight, 300. That's a stoichiometric calculation. Only we didn't give the grams of ethylene. To make it easy, we give a mole. Then ask you to calculate the moles of ethanol. Then you have to get the grams of ethanol. That's how you get the answer. If you can do stoichiometric calculation similar to this, you are in good shape. Limiting reactant is another idea. When you mix up chemicals, at the beginning there's no products. It depends on stoichiometric ratio. If you mix up 4, 5, and 1 limits the reaction. because once the oxygen is consumed, there are going to be leftover excess nitrogen. And the products are limited by oxygen. Oxygen is called the limiting reactant. Excess reagent is the nitrogen. So looking at amount of reactants used in the chemical reaction, you can tell which one is limiting. Normally, one of the chemicals, for example, if you do a reaction in water, water is in excess. Therefore, water is not the limiting reagent. Therefore, stoichiometric calculation should use limiting reactant. Limiting reactant is like in a recipe. If you have one of the ingredients, hamburger buns, are excess, beef patties going to be limiting how many. That's the limiting ingredient. Same idea. Chemistry is also similar to cooking. We use ingredients. Ingredients are reactants. Products are the baked, cooked items. Complete the following equation. Before the reaction, 12 grams, there's no products. Before the reaction. That's 1 mole. Carbon has a molar mass of 12. 12 divided by 12 get 1. 64 divided by 32. Oxygen is molar mass is 32. 2 moles. If you compare 1 to 1, you can always see this is going to be limiting. Why there's 1 mole, that's 2 mole. Excess 1 mole or 32 grams of oxygen going to be excess. Only 44 grams, 1 mole of carbon dioxide. 44 is the formula mass of carbon dioxide. 1 times 44 is 44 grams. That's how you get the idea into predicting reactant grams. How many reactant grams are converted to product grams. Now, pictorially, I talked about this. You can look at ratio 1 to 1. See how many of them are in excess or greater quantity. So these gray circles, large gray circles are limiting. A is the limiting. For this reaction, 1 to 2. Therefore, there should be more B in the reaction. So B is the small gray circles. They are not in excess. You need more. But you have, therefore, B is the limiting reactant. So we go on over limiting reactant. Now, once you've done the limiting reactant, got the product yield, that's the theoretical yield based on the stoichiometry. The calculated grams of products are called theoretical yield. Actual yield is real experiment. Therefore, comparing actual yield to theoretical yield shows the efficiency of the reaction. So we use this idea. Percent yield is how good your reaction is. Actual is what you obtain. Theoretical yield is the possible maximum yield calculated based on the chemical equation. Actual is practical. You go and do the lab work, there are going to be less products. Therefore, if the percent yield is 100%, that's a good reaction. Less than 100% means efficiency is going down. So you are given question, 32 grams of methanol with carbon monoxide and obtain, that's a reaction between methanol This reaction is methanol plus carbon monoxide give you acetic acid. You start with 32 grams. Molar mass of methanol is 32. You can add them up and see whether you get them. So 1 mole. 32 divided by 30 is 1 mole. At the beginning, you don't have any. Before the reaction, you don't have any acetic acid. Theoretically, this is the limiting reactant. You get 1 to 1. You get 1 mole of formula mass of acetic acid is 60. You can add up all these hydrogen, carbon, oxygen. You get 60. That's the 60 grams. 1 times 60 is 60. Actually, is the real yield. Therefore, efficiency is given below. 50 divided by 60. Actual yield divided by theoretical yield multiplied by. That's going to get how you get the theoretical yield. For this example, theoretical yield is given. Actual yield is given. Calculate the percent yield. You have the equation here. You plug in actual yield, theoretical yield multiplied by 100, 89% efficiency. So if you have percent yield given, theoretical is actual yield. So you have to rearrange this equation to obtain this equation. Then you plug in percent yield, theoretical yield divided by 100, you get 7.93 actually. So these are calculations about efficiency of a stoichiometric, efficiency of a converting reactant to products. So I am going to have only up to theoretical yield. So you're going to have a test on Friday. Just go through more problems and carefully go over what I describe here. You can go back to Zoom meetings or what I was explaining if you didn't understand. Okay? I'm going to stop the class today. I might come back on Thursday, 1 o'clock, if you have any questions. But the test is going to be on Friday, 8 to 9, 10:30. Do you guys have any questions? Are you guys here?
We here.
All right, then you guys have a come back on Thursday if you have any question. Thursday, 1 o'clock, I'm going to be here. Okay?
Okay.
Okay,
Okay,
take care.
you have a nice day.
Yeah, bye-bye.
Thank you.